Good afternoon, guys. Welcome back into my channel. So in this lab and lecture, we're going to understand and configure, verify a site-to-site IPsec VPN using the CLI command. So you could see here it says IPsec fundamentals. So IPsec is a framework of open standard for creating highly secure virtual private networks, VPN, using various protocol and technology for secure communication across some secure network, such as the internet and IPsec tunnel, provide the security service listed in there. So these are the services listed. Now, sorry guys. Now you may wonder, what is a site-to-site VPN? So a site-to-site VPN is a permanent connection between function as an encrypted link between offices. So this is a typical setup as an IPsec VPN network connection between networking equipment. You get one router and you get another router. In between those two routers, just like this, in between those two routers, you get an IPsec tunnel. An IPsec VPN tunnel. Let's go back to the lecture. Now you may wonder, what really is IPsec tunnel and how is it made? So IPsec tunnel is an internet engineering task force, IETF standard suite of protocol between two communication points across the IP network that provide data authentication, integrity, and confidentiality. It also defines the encrypted, decrypted, and authenticated packets, the protocols needed for secure key exchange and key management are defined in it. The whole used for IPsec tunnel, you could use IPsec tunnel for all these following: to encrypt application layer data, to provide security for routers, sending routing data across the public internet, to provide authentication within encryption, like authenticate that the data originate from a known sender. It also to protect data, to protect network data by setting up circuit using IPsec tunnel in which all data is being sent between the two endpoints is encrypted as with a virtual private network VPN connection. So the services that IPsec security services, the services that provide, you could create a peer-to-peer connection, authentication. The description of that is to verify the identity of the VPN peer through authentication. The method used is those two methods here, the PSK and the digital certificate. Now, also, it uses for data confidentiality. The description of that is to protect data from eavesdropping. That's a security methodology. And attacks through through encryption algorithm, change plain text into encrypted ciphertext. So the method it used is DES and 3DES, which those two here are not recommended. The one that's recommended is what is the EAS. These two here doesn't recommended, but this one is recommended. So that's the one, the Advanced Encryption Standard EAS. Now you also could use, and also the security service it also provide is data and integrity. So it prevents man-in-the-middle attacks by ensuring that data has not been tampered with during its transit across an unsecure network. It uses the MD5 algorithm, secure hash algorithm, SHA-1. It uses the MD5. The MD5 is not recommended. So it also replay the detection. It's prevent man-in-the-middle attack, where an attacker captured the VPN traffic and replays it back to a VPN peer with the intention of building an illegitimate VPN tunnel. So every packet is marked with a unique sequence number. If VPN devices keep track of this sequence number and does not accept a packet with a sequence number, it has already processed. Now the authentication header and encapsulating security payload, ESP. So you could see here, you could take your time and follow along with all these. So guys, it's explaining the EAS encryption. So the original header, the protocol one, is equal to ICMP, 6 is TCP, 17 is UDP. So the IPsec transport mode, protocol 50 is equal to ES. So you could take your time here and just go follow along with these and understand that it says that DS is 56-bit, symmetric data encryption and stuff like that. So you could see we have, why don't we go ahead and pull packet tracer and start our configuration with IPsec tunnel. So now guys, first thing first, in our configuration on the first part, like note that on our first configuration, we have to use the routers have been pre-configured with the following commands. So we got to use, let's say, exit out. Now we got to use password so we could log into the router. So password, yeah. Okay, so let's go. Yeah. Am I correct? Password is asking for here. Is access only. Was it? Let's exit. Let's see. Tell you what, hold up. Let's go ahead and see what do we get. So it asking for passwords. It's you know what? Doesn't take it. Let's try a different password. Says okay. So we enter the first password. Now we got an EN, and now we get the second password. So it's pretty secure. So we got the second password. Now let's try the conf key. Okay. So now if we test ping PCA to PCC and see if we get a configuration. I mean, if we get a ping. So let's test ping PCA to PCC. So PCC is .33, right? Man pump, let's see, or power. So we got a ping. All right. So now let's enable the security technology packages by using the following command on router one. It's pretty secure. So let's do license boot module C1900, then do technology package security K9. Now we're gonna accept the license, and then we're going to save the running config and we load the router to enable the security. Gonna accept it. We're gonna accept it. Then we end. Right? Now, let's do copy, run, startup config, and then hit enter. Okay. Now let's hit reload. Yes. Okay. So we're gonna save, reload the router to enable the security license. Now after that, we're gonna verify that the security technology package has been enabled by using the show version command. What password do I have to put on here? Oh, password getting to me, but this is for the sake of this lab. So you gotta do what you gotta do. Okay, guys. So now it's asking for password. Let's see which password we gotta use here. It says call console PA. Right. Then we get enable the second password again. Let's go. Yeah. Right, that's the second password. Now let's do a show version. Oh, does it take it? Show version. Now you could see. Now you could see that. Now we're gonna identify interesting traffic on router one. So we're gonna configure the ACL 110 to identify the traffic from the LAN on router one to the LAN on router three as interested. So this interested traffic will trigger the IPsec VPN to be implemented when there is traffic between the router one and router three LAN. All other traffic source from the LAN will not be encrypted because of the implicit denial. So there is no need to configure a denied IP any statement. So let's go ahead and try from router one. So from router one, what we're going to do is, so here you can see the security that we have that we have updated the router to, it takes place. Tell it here. It's the version that we have. So now let's do conf t and do access list 110, and then we could do permit, oh, sorry, space permit 192.168.0.0.0.255. Then we get 192.168.3.0. Then you get 0.0.0.255. Okay, what do I go on? So the permit, we didn't put the IP. That's where we go on. Okay. Permit, IP, right there, and we should be good. Okay, guys. So now, on these steps, we're going to configure the IKE phase 1 and ISAKMP policy on router 1. So we're going to configure the crypto policy 10 properties on router 1 along the shared crypto key VPN PA55. So note that the higher DH group currently supported by Packet Tracer is group 5. The production. So therefore, the only encryption method, key exchange method that we could use is the DH. Now, go ahead and do crypto ISAKME policy scan. We could do encryption, AES 256, the highest. Then we could do group 5, then we exit. Let's go ahead and do crypto ISP. Now we're gonna do the VPN PA55. Let's do it lowercase just to avoid VPN PA55. Address 10.2.2.2. Okay. So now on this step, we're going to configure the IKE phase 2 for IPsec policy on router 1. So we're going to create the transform set VPN set and use the ES-AES and ESP-SHA-HMAC. Go ahead and do that. We're gonna do crypto IPsec transform set. So let's do VPN set. Then we could do what? ESP dash AES dash ESP dash CHA dash HMAC. Okay. So now we're going to create the crypto MAP VPN that binds all of the phases two parameters together. We're going to use the sequence number 10 and identify it as an IPsec ISA KMP map. So water one, again, let's do crypto. Oh, sorry. So crypto VPN, VPN map 10 and IPsec dash ISA KMP. Let's try that again. See where we go on. You have what? Crypto. Oh, do we have? So it should be crypto map. That's where I go on. So it should be crypto map. It should be crypto map VPN dash map 10 IPsec. Okay. That says now note this new crypto map will remain usable until a P and a valid access list have been configured. Not a problem. So crypto map VPN and IPsec. Okay. Now we could do description VPN connection to router 3. Then we could do set peer for the IP address. Let's see something. This IP address. Okay. For IP address. Oh man, what am I doing? Whatever. We could do set peer. All right, so it's 10.2.2.2. All right. We could do set transform set say VPN dash set. Okay, now we just have to match the 10 the 110 address 110. And now let's exit out, guys. Okay, so now in this step we're going to configure the crypto MAP on the outgoing interface. So we're going to bind the VPN MAP, crypto MAP to the outgoing serial of 00.0. Let's go ahead and do interface serial 0.0.0, right? So let's do crypto map a VPN map, which is MAP. This says, oh, I see. Yeah, there's an error here. It's not on this course, so thank you, Bengo. Okay. So it says the crypto, as you can see here, there's a message here that says that it's on. Now, in this step, we're going to configure the IPsec parameter on router 3. So on router 3, let's go ahead on router 3, make it bigger. See if we have the same headache. Yep, we do have the same headache. So let's go ahead and type in all this password. This is secure. Apologize for that. So this lab may be longer than expected. So Cisco PA. Right. Okay, so again, and another password again is Cisco and PA plus 225. Okay, so we in. Conf T. All right. So now for router 3, let's do show version. Do show version since I'm already here. Do show. Check out the version. More. Okay. Version. Oh, I got a version. Okay. Software release. All right, guys. So now we're going to configure the reciprocating parameter on router 3, configure ACL 110 to identify the traffic from the LAN on router 3 to the LAN on router 1 as interesting. So let's go ahead and make that. Let's do access list 110 permit IP 192.168.3.0. And we could do what? 0.0.0.255. And we get 192.168.1.0. And you get that 0.0.0.255. Okay. Now, we're going to configure the IKE, the IKE phase 1 ISAKMP properties on router 3. So let's go ahead and do crypto IS policy 10. We could do encryption AES 256. Then we could do what? Authentication let's remove this, pre-shared. We could do group 5, and then we exit out. We could do crypto AKM key. Let's put it VPN PA 55. Oh, VPN PA 55. So we haven't done yet. Command is incomplete. Gotta do the address, which is 10.1.1.2. Uh-oh. I say 1, but I type 2. 1.2. Okay. So now we're going to create the transform set, the VPN set to use the ESP-AES and ESP-SHA-HMAC. So let's go ahead and do that. So let's say crypto IPsec transform set. So we're gonna say VPN dash set, sorry, ESP dash AES dash ESP dash SHA dash HMAC. Okay, so now we create the crypto map VPN dash MAP to bind to all of the phases to parameter together. So we're going to use the sequence number 10 to identify it as an IPsec. Okay, so let's do crypto map VPN MAP 10 to IPsec. See if I take it. Yep. Let's do description. VPN. Do connection. There's a ticket, so connection to R1. Okay. So now let's set the P to the IP address of 10.1.1.2. Then we could do set transform set says VPN set. Okay. Now we could do match address 10. So map address instead of 10, it's 110. Okay. Valid access list name. Yeah. So let's exit out. Now, and in this step, we're going to configure the crypto MAP on the outgoing interface. So we're going to bind the VPN MAP crypto MAP to the outgoing serial port, serial 0/0/1. So let's do that. To interface, serial, do crypto MAP VPN MAP. Okay, now it says it's on. Now we can verify the IPsec tunnel, the IPsec VPN. So we're gonna verify that prior to the interesting traffic. So let's do that. Let's do let's X out one step. Let's say do show quit up, and that's what I don't like when I type the whole IPsec. Yep, IPsec. SA. Right. So now, notice that the number of packets encapsulated and encrypted, decapsulated, and decrypted are all set to 0. Right? See, all of them are set to 0. Now, you can create an interesting traffic by pinging PCC from PCA. Let's go ahead. From PCA, let's pop out. Now, we can verify the tunnel after the interesting traffic. Router 1. Okay. Let's go on router 1. Sure, we got it. Got to access the password again, if I'm not. Okay. Thank God it doesn't access for password. Let's do show crypto IPsec SA. Now, notice that the number of packets is more than 0. So it's more than 0, which indicates that the IPsec tunnel is working. So we could create an interesting traffic from pinging PCB from PCA, and then PCB from PCA, PCB from PCA. So it's the 2, the 3. So about change this to 2. B from PCA, I bang. So not that if we're showing a ping from router 1 to PCC or router 3 to PCA, it's not going to work. So router 1, PCC, router 1 to PCC. So let's ping PCC from router 1 and see something. So let's exit. Say ping. 192. Let's exit. Yeah. So you see it's not working. Okay. So guys, this is pretty much. So let's issue a comment from this here and do. Okay. This is something here. What a 3, what the tunnel is this? Still do show crypto IPsec. Yes. So it's command like that notice that the number of the packet has not changed, which verifies that the interesting traffic is not encrypted. Hold on. Right from B. Water 1. Let's do crypto. Crypto. IPsec. Yes. It says the change is expected to be and then it's done. This is local address. So guys, this is pretty much all that we, so there's a good, maybe the compass field 0. So that's pretty much all that we got to do with this lab. So thank you so very much for following along with me. I appreciate you every time we get the chance to work together. So stay tuned for more interesting lecture and demo for the CCNP Encor. Okay. Start sharing. Make this start.